All right, this is 6.1. We're looking at exponent properties, but now we're applying those properties to scientific notation. So let's give this a shot. In these first two examples, we are going to be multiplying. If you look right here, we're multiplying this scientific notation number with this scientific notation number. When we do that, when we multiply numbers together in scientific notation, we multiply the coefficients together. Then we add the exponents. Then if the new coefficient is not between 1 and 9.9, we need to rewrite in scientific notation and adjust the exponent. We'll talk about that in a second. So let's do this first example. We're taking 1.2 times 3.4. Those are the coefficients out in front. And we get 4.08 times 10 to the power of whatever 3 plus 2 is, which is 5. So that's temporarily a correct answer. Now stop and assess. Is this number right here written in scientific notation? Is there only one significant figure to the left of the decimal point? Is there only one digit there? Yes, there is. So that is the best answer. I paused there because you're going to see what happens on number 2. So again, we're multiplying 7.3 times 8.1. We get 59.13 times 10 to the add the 5 and the 2 together. That gives you 7. Now, this number right here is non-scientific notation. If the new coefficient is larger than 9.9, move the decimal point to where it should be. Should be between the 5 and the 9. And that 1 and 3 just comes along after the 9. But when you move the decimal point, you need to add the number of place value decimal points. Add the number of place value decimal point was moved to the exponent. Add the number of places the decimal point was moved. So that's worded poorly. We moved it one spot, so we're going to add that one spot to the exponent, to the power. So it's going to be times 10 to the 8th. Oh, add the number of place values. The decimal point was moved. I think that'll work. Subtract the number of place values. The decimal point was moved. All right, let's move on to dividing. When you divide numbers in scientific notation, you divide the coefficients together and you subtract the exponents. Now subtracting order matters, so you're going to take the top minus the bottom. And you might want to use a calculator on that. You're welcome to do it in your head, but then double check with the calculator. So here we're going to take 6.8 divided by 3.4. That is 2 times 10 to the, what's the power on the 10 going to be? Take 5 minus 2. Top minus bottom. That gives you 3. There we go. And this number is in scientific notation. There's an invisible decimal point right there after the 2. So we're good. Next example, let's take 2.2 and divide it by 4.82. You get, and we're going to have to round here a little bit because this decimal is messy, 0.4, whoa, I'll try that again, 0.456. Let's call, the next digit is a 4, so let's just round it to 3 decimal places, and it will be 0.456. Times 10. Now here, you're going to take 3. So I can't see where I'm writing right now. If you're thinking this is sloppy, that is true, it is. But it's hard to write right now. You're going to take 3 minus the bottom number, which is -1. And if you remember your rules with integer operations, subtracting is the same as adding the opposite. That's why your calculator is going to tell you that you get 4 here. However, if the new coefficient is not between 1 and 9.9, which it's not, it's 0.456, that's less than 1, rewrite in scientific notation and adjust the exponent. So if the new coefficient is smaller than 1, move the decimal point to where it should be. So it should be 4.56. Now it's going to be times 10 to the, subtract the number of place values. The decimal point was moved to the exponent. So we're going to subtract that 1 decimal place from the 4. If you type, and so to understand what's going on here, folks, if you type this carefully in your calculator, here in yellow, that's going to be equal to this. But if we're working with scientific notation, we want our answer to be in scientific notation. So that's where this answer is the best, because it's the answer to dividing scientific notation in scientific notation. Last but not least, what do we have here? We have scientific notation raised to a power. Numbers in scientific notation to a power. What's the rules there? You're going to take the power of the coefficient, and then you're going to multiply the exponents. And then same thing. If you have to adjust those numbers, do that. So I'm taking 2.5 to the second power. 2.5 to the second power is 6.25. Times 10 to the, multiply your powers together, you get 10. Cool. Let's try number 6. Take 6.5 and raise it to the 4th power. You get a huge number. You get 1,785. I'm going to round it there. I should actually technically round it to 1 place value since they're using maybe 1 digit perhaps. We're going to round there. Instead of 0.06, we're going to call it 0.1. Times 10, multiply your powers together, that's 12. However, this number right here is not in scientific notation. The decimal point needs to move there between the 1 and the 7. So 1.7851 times 10 to the what? This number was too large, so you need to add the number of places the decimal point was moved to the exponent. So it's going to be 12 plus 3 because it moved 3 places, so it's 10 to the 15th power. These 3 places got added to the power.